Hello, ladies and gentlemen. Let's go over the first example on your worksheet. There are two displacement vectors, one of which we'll call D1. It is 6 meters at about 15 degrees. Call this D1. And then D2 is 4 meters at 45 degrees. Is that right? There. I'm going to throw in some little coordinate axes just for reference here. We'll call this theta 1. Up here we'll have theta 2. So we'll have those for reference when we break them up into their components. If we look at the components of D1, we'll see we've got D1's X component like so, and D1's Y component like so. Do the same for D2. Here's D2's X and D2's Y. So again, we can see that the resultant vector is like so. Remember that it's made up of both D1's X and D2's X as well. Here we have D1's Y and D2's Y is going to make those up. So this one fairly straightforward. D1's X, remember, is just going to be D1 cosine of theta 1. D1's Y, D1 sine of theta 1. D2's X, D2 cosine of theta 2. D2's Y is sine. Alright, D2 sine of theta 2. We can solve for these right now if we like. We know that D1 is 6.00 meters at an angle of 15 degrees. Do make sure that you've got your calculator in degrees and not radians. So D1's X, in this case, the X component of D1 is going to be something like 5.7955 something. Meters. Don't forget that it's meters. It's a displacement vector. Okay? You want to keep this long number in your calculator until we actually use it. Alright? Here we have D1's Y, which is, again, 6.00 meters times the sine of 15 degrees. So D1's Y is going to be about 1.5529 meters. So we've got the X component and the Y component of our D1 vector, first displacement vector. We can do the same with vector 2 there, and we'll get, in this case, 2.8248 meters. Sorry, 2.8284. And because it's a 4590 triangle, the Y component is going to be the same magnitude. At this point, we're just going to be adding these numbers together, right? So D1's X plus d2's x will give us the x component of our final displacement vector. So you're going to have to use the same numbers that you've got in your calculator, right? That was 5.7955 meters plus 2.8284 meters. And your calculator should give you some value like 8.62398. Your calculator won't give you meters though. Okay? Mind you, this is not our final answer. We're not rounding this value yet. This is just the x component of the resultant vector. Now if we do the same for the y values, right, d1's y plus d2's y, we're going to get a value of 4.83813. Again, keep the same amount of digits that you've got in your calculator. So hopefully you've stored both of these numbers because we're going to use them again because the question asks us for the resulting vector, which is both its magnitude and direction, not its components. So we have to take these components and use Pythagoras on them. Okay? Pythagoras, of course, being that the magnitude of our resultant vector is equal to the square root of, equal to the square root of the x component plus the square root of the y component. So these values are what I've just calculated by adding those two together. So d is the square root of 8.63298 meters squared. It's 4.3813. Alright, so we're using Pythagorean theorem with this, and we get a value of 9.6731. Etc., etc., etc. Alright, this is part of our final answer, so this is a number we are going to round in this case. We were given 3 significant figures. I know you like that. Alright, so the magnitude is going to be 9.67 meters. Oh, no, we're not done yet, because remember, this is a vector, it has both magnitude and direction. So again, we have to use these exact values to find the angle at which our resultant vector lies. Okay. So again, theta is going to be the inverse tangent of the y component of d divided by the x component. In this case, again, you're going to have to use the same values that you got in your calculator for an accurate value. So it is, sorry. Okay. In doing so, theta of our resultant vector is going to be 26.932 something degrees. Okay, we'll round that to 3 significant figures for you. You've got 26.9 degrees. So in the end, we have a resultant vector that is 9.67 meters at an angle of 26.9 degrees. And that is our final answer.